Hey folks, so the first video here disappeared. So another quick video on uh, the Physics 9 dry ice puck slides down ramp. This title may or may not be there when you're looking at it, but the dry ice puck slides down the ramp. That's what we're looking at. So when you open this up, you'll probably just see it like this, where we see the learning objectives and the dry ice puck. It's worth noting that then this dry ice puck, we see the little arrow thingy there. It's possible that when you first open it up, that you don't see any of that. So when you first open this thing up, you might just see learning objectives like this. You might see this as well. This first spot here is just showing how the physicists, the lab folks, uh, prepared the dry ice pucks. It's just kind of a cool deal. So they included it, and I thought we'd leave it there. You could look at it if you want to. This is where we have the activities. This is where we're going to be doing stuff. Make sure you're aware that whenever you're done with one spot, you need to look to make sure you are prepared to work on these next sections. So the first part, clicking on that thing, and there we go. So this video goes through. It has a piece of dry ice that's actually carbon dioxide that's in the air that we exhale. Carbon dioxide, if they kind of putts with pressures and temperatures, they can compress it and freeze it. So dry ice is actually so cold, it's carbon dioxide compressed and frozen down, so it's a chunk of solid instead of a gas. Um, and it can be a really low friction sort of a deal. Um, when this thing goes through, there's just there she goes of that puck sliding down. We can pull these tools out. There's a protractor to measure angles. We really don't need that. There's the stopwatch for time. Yeah, we'll probably need that. And then there's a meter stick. And that will be helpful as well. It is possible to take the meter stick and rotate it, um, and that is a helpful thing when we're on this incline. So to take the meter stick and have it lined up so that it's matching the angle of the ramp. And then I would also suggest lining that meter stick up so that the very front edge of the meter stick is right along with the edge of that puck. Then our original position where the object is starting off would be 0. That's just a helpful starting point. And this is another one of those where it's helpful to kind of advance the frame until the puck is just starting to move. We want to find that starting point. Oop, started to move. Okay, so there, being cut, gone. So I would at that point kind of say, hey, I'm going to set that clock to 0 seconds. So now we're ready to go through and record these measurements for the location of the puck and the time it is at that location. I am using the ramp angle number 9, massive puck A420. 420 grams. So the um, suggestion or the request here is that if your last name starts with A or B, try to use puck A. If your last name starts with C or D or E or F or G all the way up through L, use B. So I guess with me being Lulai, I should probably change that to B. And then I need to scoochie my, there we go. And I need to find the spot. right there. So I'm going to make that 0. So now I've actually gone back and made sure I follow the directions. So I am using puck with mass B. I'm using a puck with 180 grams. I am staying at ramp angle 9, like it says up here. And now I can measure the position of the puck. Uh, I'm going to go with the front edge. I'm going to measure the position of the front edge and the time. And then those data points I'm going to enter in down in these spots. The velocity column we're going to leave blank actually for this entire experiment. Actually, it's a change that we made. So we'll collect some data points here, and then it should plot off. So we have our position time graph in here, and then we have this spot that goes through and just asks some questions for the data collection part. So I'm just going to go through and take my first data point is, and we already kind of went through and, oh, where did my stopwatch go? Oh, so we said we're at position 0, time is 0. So I'm going to scroll down here and I'm going to say time 0, position 0, and that's good. One of the things that a few folks realized and some folks didn't quite see is that we don't need to actually collect data for every point along this motion. We can skip some spots. I'm going to click forward a bunch of frames and go through to where we've got here 0.2167. That's a fair chunk of the way through. But it does say here that we should try to use uniform steps. So we're going to definitely avoid just clicking forward one frame. We're going to try to click forward until we're either at 0.1 second intervals or possibly 0.2 second intervals. Um, I'm already at 0.1 right now, so I'm just going to stick with that. So my time's zero point 0.1, and that's at if that's 0 and that's 10, that makes that 5. I'm going to say that's about 3.2 maybe. The time was zero point 0.1. So we've got that. And now, like it says, if we're going to try to stick with our interval of zero point 0.1 seconds between, so that means that I'm at time 0.1. I'm going to just keep on clicking until this time changes to 0.2 seconds. There we go. 0.2 seconds. And the position is now, that's 5, that's 10. That looks to me to be about 8. So that was zero point 0.2 seconds and 8 centimeters. And then we're just going to keep on going until we have about 10 data points. When we get to the graph part in here, we'll end up getting things lined up. We'll have a bunch of data points. Remember to go through and add a curve fit. Um, Once you have all of your data, then you can check between and compare between linear or between uh, a quadratic. You can either use the square law or the quadratic. So check linear, square law, quadratic. Okay. And then whatever you get, you'll have the equation down there for that. And then you should be able to go through and answer these questions. And this is just double checking, hey, which puck did you use? Making sure we're aware of that. And then uh, some questions here about your use of the tools, making sure you have stuff. The question here, there's all of this here, and then the question is right there. Describe the shape of your graph. So this is just a spot for you to describe the shape of your graph. Then the analysis questions talks again about properties of the graph, slopes, y-intercepts, area under the curve, stuff like that. Um, and it's a spot for us to try to hopefully figure some of that stuff out. So this data we're going to use to figure out the next. This is going to kind of start our next section of work. So good luck going through there. I think the data collection part is a doable deal, and I think once you get to the analysis questions, I think they will make some sense. If not, please add comments or questions to Google Classroom, and I will try to get back to you as quickly as I can. Thanks, folks.